Okay, welcome back. Just let me revise back the surface integral example 3, and this was the question that I stopped at, but I will revise this very quickly. How to find out the semi-hemispherical? It's not a semi, octant, okay, quadrant base hemispherical surface, especially for this goes F equals to yi plus 2j k. This is the goes the force exists over a surface as defined by the surface creator. The spherical radius is a 3. Okay, radius is a 3 if you checked, and bonded by the quadrant here, which is x is a greater than 0, y equals to greater than 0, z equals to greater than 0 in the first octant. We have been requested to evaluate the surface integral. Therefore, we need to evaluate the whole. Okay, we know we need to identify the OAB. Okay, ABC, OAC, OBC. Okay, then in a previous lesson, I have done with you ABC, how to find out OAB, OAC, OBC. But the problem with this surface, especially ABC, is not a smooth surface, and I did started with this. Okay, now it's a kind of continuation, just very quick revision with you, and I did mention with you that ACB and cannot determine using normal method. Okay, which is the surface is not a smooth anyway. Okay, the surface is not a smooth, therefore it is not a smooth surface. Therefore, we need to calculate the gradient. Okay, how to calculate the gradient? And you have seen the calculations is a very straightforward as usual for the gradient. Okay, and I did explain to you how to find out, and it's a kind of revision again. Okay, and we found the n exactly as xi plus yj plus zk divided by the 3, and f dot product to the end, we got the answer xy plus 2y plus z, and here is a 3. And as a continuation to that, okay, we learned something what we call it as for the spherical method. Okay, for the spherical method, very quick one, quick revision, because I stopped because my camera stopped halfway, therefore I wanted to continue that. Okay, x2 plus y2 plus z2 equals to r2. It's a spherical method, therefore we cannot use shadow surface in order to find, okay, in order to find the surface called ABC. This is, I think, is a B and C. We cannot use shadow. What is the reason? Because it's a 90 degree. Okay, at this point and to this point, end point, definitely it will be a 90 degree. Therefore, you will get a 0. If you total up for the gradient, you will get a 0 if you use a shadow. Therefore, it's impossible to use a shadow. Therefore, we need to use actual surface to calculate the the surface of smooth surface of spherical method. Okay, now I did explain to you how to find the surface, of what you call the spherical, and we have done several times. Okay, but this is a horizontal portion of the spherical. And horizontal, we need to use rho sign as our R. Okay, our R. Okay, then you can see if I wanted to sketch the whole, this is a revision again. Please refer to the revision. Okay, this is very important. I refer to the R because I cannot go back and again explain in detail. And this is R, rho sine phi. This is a del theta. And okay, in order to find out this circumference here, you need to use rho sine phi d theta. It's understood, right? R times R d theta. Okay, in order to pull up this, okay, we need to use here, let's say I pulled a little bit up here. Let's say you can imagine. Okay, what is this? Okay, this is actually rho. If you start looking at this, it's a phi. It's not a horizontal anymore, it's a phi, d phi. Okay, the d phi here is a kind of thing. It's not a straight line anymore, it's a kind of curve. It's a curve that is forming here. Okay, it's a d phi times with the rho. Okay, the rho. You can ask me what happened to the sign. Actually, I already told you several times, this is a horizontal. Okay, this is we are pulling this up, vertical. Okay, vertical. Therefore, rho d phi, then you get a kind of the upwards surface. We just say rho d phi. Okay, therefore, it actually I'm trying to coach you to create your own formula. Otherwise, if you don't learn this skill, impossible for you to remember all the, it's not to say impossible, and you won't know how to apply the logics of what you call the surface creations there. Okay, therefore for you it's impossible to design the formula what we call spontaneously according to the scenario. Okay, therefore you are here, you need to use a ds, the surface here, this times this. That means the circumference calculate with the vertical circumference of the surface. Okay, then we add up here, we not add up, we are times with that product, you get a ds. Okay, and I did explain also, okay, x is before we have done for the spherical coordinate system, rho sine phi cos theta. Rho sine phi is as simple as this. It's similar to what I call what you call polar coordinate model, r cos theta, r sine theta. As long as you can understand, okay, let's say if you understood the logics of the spherical coordinate, then we just substitute, you will get the whole equation. And we have done up to here. Okay, we have done up to here to solve this problem. Okay, is it because in a previous class, okay, we stopped at this place. Okay, is it enough to solve here? No, we need to substitute everything here. Okay, we need to substitute every the x, y, z, the z inside here, okay, to calculate. This looks very lengthy. Okay, normally the student get really upset with this and looking at this kind of things. Okay, it's required very important things here is a patient to do it. Okay, you cannot simply, okay, I wanted to do it very fast or the solution. It require very simple patient. I'll taking out here. Okay, you need to, okay, it's a little bit tolerance required here. X, y here, x to the y is look very complex. Rho sine phi cos theta. Okay, y is xy, right? Rho sine phi. Okay, sine theta. Okay, and plus 2y is a rho sine phi sine theta. Okay, z z is a rho sine phi. Okay, is it finished here? Rest here. Rho sine phi d theta d phi. Wow, it's look very long. Okay, but you can solve it comfortably, but step by step. I may say it's required, as I say, a little bit tolerance is required here. You cannot expect it look complex. Actually, you may say, wow, so complex. No. Practically, you need, as I say, organize this very in a simple and order. If you make it this little bit orderly manner, you need to combine and do it like a step by step. Later, I'm trying to teach this in a separate way to handle this problem. But you must have something. First, continue. You should continue. You cannot simply, for example, here I say 1 over 3. Okay, then collect back all these things again. Okay, when you collect, okay, this one you need to bring it out. Okay, wow, I forgot this. Okay, this one will go inside, Therefore, is a row. I cannot put it this as something. It should go inside. Okay, when it go inside, here this is a row 2, and this is x2 to the 2 is there. Okay, now in total you should get here 3. Okay. Maybe I okay, we organize that one by one. Okay, when this is a sign. Okay, when just combine this sign. Okay, row 1 2 4. Okay, and sine phi. Okay, combine 1 2, that 4. You get here sine phi 3. Okay, and you get this as a cos theta sine theta. Okay, we have done the first portion, right? Okay, done. Okay, the second one. Okay, am I miss anything? No. Okay, the second one here, 2 phi 3 sine phi 2 sine theta. Okay, and am I miss something? I don't know. Yeah, I missed something. Okay, z. I miss z here. Okay, 2. I just say combine this 2. Sorry, because space is okay. I say xy here. Xy, yes, correct. 2y, yes, 2y. We have done. Okay, and I miss this. Okay, I miss this. Suppose can I do? Please excuse me. Okay, z is a rho sine phi here plus. Okay, now let me combine everything first. Sine theta, yes, this is sine phi 2 sine theta, yes, this one will come to over here 2 plus what is this, 2 3. Okay, 3 oh, am I made a mistake here? Yes, seems to. This is z. Wow, again, too many mistakes here. Sorry, it's a cos phi. Okay, cos phi. Okay, cos phi. I mean, some student may get confused why I put here. Okay, this is rho sine phi. Okay, cos phi. Okay, this is correct. This is r sine. this is r cos, this is cos phi, okay, rho. Okay, in this case, this is cos phi. Okay, therefore, you will get over here cos phi sin phi. Okay. Okay, now I just segregate this separately. I will help you to handle one by one. Okay? Okay. Now, is it clear? Oh, you all didn't see that, huh? Okay, again. Wow, it's like a very lengthy kind of things. Okay, please have a look on that. Okay, please make a corrections here. Okay, from the previous class. Okay, rho sin r cos theta, y rho sin phi sin theta. This is z rho sin phi. Okay, and okay, fn, this become complex. When you just substitute, it's look very complex here because I made a small mistakes here. Please bear with that. Okay, but over here I already corrected. Okay, I already corrected here. Rho we calculate. Okay, we calculated here. Okay, xy2. Okay, therefore it's overall we get what rho 4. Okay, now can I ask you to do, okay, in order to solve this, let's say this is the case, okay, this is the case. Okay, how to solve this problem? I recommend split it into portion. Okay, we can do it this portion by portion, no problem at all. Okay, we can take it, this is the first portion, you see 1, we take it that as 1 over 3. I take it the first portion as I1. Okay, and this one I call it as I2. Okay, this one I call it as I3. Okay, just to, because you can bring it inside, this is a theory supported by d theta d phi, no problem, you can bring inside, no issue at all. I want you to see the problem very clearly because I don't want to mess up first. I can go inside, no problem. But this one, you can see this one here, okay, no problem, we can split that into 3, okay, just to help you to solve this kind of problem. Or some of you might be very good, straight away you can solve here, okay, because it's a very long, okay, it's a very long, therefore I'm going to do it that something, not to say I'm going to solve this completely. I hope that I initiate something to you. I hope that you can complete this by yourself. Okay, now in this case, as we have done from the example here, okay, now we are concentrating for the ABC. Okay, ABC, for the ABC, for the continuation. Okay, now you can see that we started with this 1. This 1 over 3 is a disturbing here. Okay, we can put it aside, but first as I just continue pi over 2 0 phi over 2 as I1. Okay, I1 is no, maybe okay, sorry, yeah, because I started with this. I wanted to solve this by one. Just I wanted to show you this part, this portion. I'm going to solve one by one. Okay, just introduce to you. Therefore, you can imagine I1. Okay, the I1 is this. Okay, 5 over 2, 0, 5, 2, 0, rho 4. Okay, if there is a mistake, please correct. Please correct, because I'm as I told you, I'm doing this question spontaneously. Okay, d those things, because we can take it as a kind of learning together. Okay, it's a kind of the way that you can solve this problem. Okay, how do we do this? Okay, the I1. Okay, when I continue with the I1, how do we do this? The first problem here, okay, we stop I know some of you don't like this. Say, sir, can I do everything one together? Okay, please go ahead. I already told you, because certain students require this kind of help. I need to coach them step by step. Okay, look at this one. Okay, look at this d theta first. Okay, when you start looking at that, this one, in order to solve this part, okay, you can ignore this. You can imagine this is a constant. You can imagine this is a constant. Therefore, you can start working on 2 to the 0. Okay, this one, how do we do that? Okay, you can treat this as a constant, you know. I told you this is a constant. You can imagine this is a kind of A, whole thing as a. Okay, the whole thing as a, and you just concentrate on this. That means, okay, I just tell you, okay, A, you don't see this first, pi over 2, 0, okay, concentrate only on this, theta, sine, theta, okay, d, theta, okay, this part, we just concentrate on this, okay, is it okay for you? Can you understand this? Okay, now, in order to solve this part, cos pi sin pi, okay, what I want you to do is you just use a substitution method. You use a substitution method whereby you all know we can just substitute. I make it a little bit faster. Here, I hope that we already done several times this portion, because my interest is here. How to solve? Simple anyway. Okay, 5 over 2 to the 0, A. Okay, this one is a, okay, can I just quickly do it this? It's a pi over 2 to the 0 and u, okay, this is a u. When I substitute here, for example, u equals to sine theta, okay, du is a sine, cos theta d theta. Okay, can you do that? Substitute here d theta, you get a du. Okay, see, du, don't, you cannot substitute, you know, u is a, you need to change it, but I leave it for a while here, okay, because our interest first, later we just convert back. Okay, then it's a pi over 2, 0, a, don't disturb the a first. Okay, here you get a u2, right? U means is a u power 2 over 2. Therefore, I just converted this to the sine pi overall 2. Okay, 2. Done. Okay, this is a pi over 2 to the 0. Is it okay? Can? Can. Okay, now you substitute here. But remember, the d phi is still there. Okay, d phi, okay, you cannot forget this d phi here. Okay, although we are solving d phi here, sorry, this we already changed it, right? This is a d phi. Okay, d phi is always there. Okay, d phi is there. Okay, later, because we're going to handle this part. Okay, now when you substitute here, pi over 2 is a 1, right? 0 is a 0, therefore you don't need to consider, is a 1 over 2. Okay, very simple, 1 over 2, bring it out. Okay, bring it out. Now, okay, we open back this. Okay, I just take it here. Row 2, I add one this. Okay, here I just concentrate on 3 pi. Okay, d phi. Okay. I'm showing the steps, okay, because some of you might feel very difficult to handle step by step, therefore I'm helping you. Okay, how to solve this part? Okay, how to solve this one? Is there any way? Just yes. Okay, this also require a substitutions. Okay, you need to use a substitution method. I teach you this. It's a d phi 4. Do you know what is rho anyway? I forgot to ask you this. Rho means what? Here. Rho is a 3 power 2, right? 3. Basically, it's a 3. Okay? Some of you get confused. Sir, you're confusing, sir. Okay. Very simple. Okay, what is the rho here? 3. Remember, this is a rho is equals to 3. Okay, rho equals to 3. Because it's a conform here, x power 2, y power 2 plus z power 2, 3 power 2, right? This is a row. Okay, this is 3 is a row. Okay, you must remember row, okay, is a 3. Okay, therefore, you no need to worry. Row is not a, what you call, in this case, it's a difficult portion to handle. Okay, therefore, you can substitute later. Okay, but here, this one is a pi over 2, 0. I help you to do this part. Sine phi, sine 2 phi d phi. You have several techniques to handle this part. Okay, I teach you both. Maybe I don't have time lah. Okay, sorry, but I'm showing that you just take it out here, sine phi here. Okay, but in this particular case, we already known to us phi 2 cos phi 2 equals to 1. Can or not? Okay, if sine 2 phi 1 minus cos 2 phi, right? Can I substitute here? Can. Rho 2, this is, as I told you, is a 3. It's a pi over 2 here. This one, sine phi 1 minus cos 2 phi d phi. Okay. Now, I know it's taking too long, no problem. Time is not matter. Here, learning is important. And here, pi over 2, 0. Okay, here, sine phi. Okay, anybody can handle this part. Here, this one. This one is again cos 2 phi sine phi d phi. Okay? Is it easy to handle? No, look complex, huh? Yes, it's look complex. But actually, it's easy to handle. You know, in what way to handle? Okay? Is there any particular way to handle this case? Yes, you can handle. Very simple. When you start convert this, okay, okay, in this case, you can straight away, you can do it, right? You convert, it become a negative cos phi. Okay, negative cos phi. What about this? Okay, you imagine again w. For example, I don't want to mix up with the u and something like that. Here, because we use a u, right? Here, I use as a cos phi. Okay, cos phi. Okay, dw is a negative cos, sine phi d phi. Okay, can you see this? Done, right? Done. W over 2. That means here w over 2, it's go up here. Therefore, 3, 2 solutions. Okay, still as a continuation for the substitution here. When you substitute the whole thing here, it's become a w over 3. Okay, once it's a w over 3, can you make it simple as quick solution here? Okay, can I start directly differentiating? Can I differentiate this? No problem, right? Okay, this one, when I differentiate here, I get a negative cos phi. Okay, done. Okay, this one, no problem. Here, when I substitute w, 2, okay, it's a whole thing dw. Okay, cos, okay, w2, when I substitute back, okay, w2 here, with this, I get a w3. w3 means it's a cos 3, cos phi 3 over 3. Okay, with this, it's a pi over 2, 0. Done. Okay, now. Okay, is there any other way other than this to handle this? Of course, you can do it in a different. Okay, you all know there is another way to handle this sign too. Okay, okay, you don't like this too. Okay, you don't want to use substitute this geometrical formula. I will recommend you to use this anyway. It's another way to later we can solve. I hope that you can solve this. Okay, you just substitute. you will get the solutions, right? It's easy. It's I'm doing it's not a difficult, but step by steps. Okay. Now when you substitute here, you see you can use a sine 2 phi. You can use another method also. It's a half 1 minus cos 2 phi. Yes, we can use this. Okay, you can ask how? Because we already learned this before, right? Okay, we already learned this before. Okay, we can use another formula, this formula, and you can use the same substitution to work with this. Okay, can or not? Okay, when you substitute here, very obvious, this is a 0, right? This is 0, this is 0, nothing to work with that, but 0 go in. Once the 0 go in, you will get a negative. Okay, negative, 1 over 3, 1 over 3, this is also 1, you will get it 1, okay, that means negative 1, okay, negative 1 and minus with the negative 1 over 3, can or not? Can, huh? It's a 3 over, what is the answer? Wow. See, while I doing the mathematics, I just follow. So 4, okay, I just see make it that 4 to negative 1, okay, just because it's a second negative, okay, negative is a positive here, okay, positive 1 and positive 1 over 3. Because this one is a 0, right? This one 0, 0, negative. Then after that there is another negative come in. Then it's we settle. Done. Okay? You know how to solve then? Because I wanted to solve this. Okay. Is it possible to solve the rest by yourself? Okay? Try to work out and see. Can or not? I think nothing difficult for the other cases all. Okay? I hope that you can solve step by step. Now, similarly, I hope that you can solve for the I2. Okay, I'll just write the question anyway. I hope that you can complete that portion. Where is my, that's the previous one. Where is the question? Yeah, I misplaced the question here. Wait. DI, where am I place it? D3 di surface. Okay, here. Sorry, I2 here. The question that you need to handle here is here for this. Okay, the next one that we are interested here is to solve this. Okay, that pi over 2 0 pi over 2 0 2 sine 2 phi sine theta. Can you do that? Can or not? Is it simple? Again, you bring it the whole thing. The 2 is not going to contribute here anyway. I think the 2, okay, 3 power 3. Okay, this one I think you can do it straight away lah. You no need to split that into, see, okay, d theta, straight away you can convert. Okay, I think this shouldn't be a problem. I hope that you can do it the first phase here, pi over 2 to the 0. Okay, here sine phi, okay, sine phi can come out, but anyway, don't touch it that first. Okay, this one is cos, negative cos phi theta, which is it's a pi over 2 to the 0 d phi. Okay, can. Okay, this one, okay, when you enter here pi over 2 0, okay, this one go in, you will get a positive 1. Okay, done. This portion never disturb you. Okay, still 2 over 3 over 3. This one pi over 2 to the 0 sine 2 phi d phi. Okay, similarly this one you make it a substitution. Okay, you make it a substitution here, 3 over 2, and when you substitute you get a u over 2. That means here, okay, you get a sine this is a u2, right? This one is not a u over 2. You will get this combination here. You need to use this formula. Sorry, I forgot to explain to you this part. Okay, again sine 2 phi. We can use 1 over cos 2 theta 2 phi. Okay, divide with the 2. Agree? Okay, therefore you can basically it's a pi over 2 to the 0, 1 minus 1 over 2 cos 2 phi 2, okay, d phi. Can follow? Can. Okay, please bear with me. If I made a mistake, please you can correct yourself, please. Okay, I'm moving a little bit. Okay, then d phi, then you just continue with that, half phi. Okay, in this case phi, this one cos 2 phi, right? Then you can do it that as a cos integrated, you get a positive sine. Okay, sine 2, therefore sine 2 phi, okay, which is you get a 2. Okay, done. Can okay, is it pi over 2, 0? Then you can solve it by yourself. Okay, I'm just saying this is a little bit easier to handle in this case. Then I hope that you can do it by yourself, Resla. Okay, I think rest of the things I think you can do it. Okay, please do for the similarly the work here is I3 you can continue for that is pi over 2 0 pi over 2 0 3 sorry, this one easy. Okay, d phi. Okay, then stop. Once you finish, you have done the whole work. Okay, this is a straightforward lah. It's not a difficult one. I hope that you can complete this part. Okay, so far can you follow? Okay, you asked me the answer. I very sorry, usually I never this thing. I request you all to solve by yourself. Don't worry about the answer, whether you're getting, I want you to learn the steps to solve the problem first. Okay, learn the steps to solve the problem, and whether you can handle these solutions comfortably or not. That's the most important things. Okay, in this part also is a similar, but this one is a theta is not exist here. Okay, it doesn't mean this one when you handle this part. Okay, some student they tend to confuse. Okay, no theta here. Okay, whole thing here is you can treat this as a b constant. If it is a constant, they may think d theta is nothing to do here. B d theta d phi. Imagine, is it a 0 or something like that? No, actually it's not. It's a constant here exists, right? Theta come out. Therefore you can see to the 0 b theta pi over 2 to the 0 d phi. Okay, then you need to solve it that very carefully. very carefully. Then you just enter here pi over 2 is a 0. Therefore, you will get a b. Therefore, this pi over 2 will come out. Am I missed the whole thing? Yes. The b, then whole thing again. Pi over 2 to the 0. Rho can be taken out, no problem. Rho is, I already told you in a previous these things. And here you can see again this one. Again the combination of phi, sine phi, d phi. Can you solve it? Can or not? This one. Combination. Okay, substitution here. You can make it as a k equals to sine phi. And here dk is a cos phi d phi. Okay, can I substitute here? Yes, can. That means it's a pi over 2. Okay, 3 over 3. And this one is a u or k power 2 to 2. Okay, therefore can I substitute straight away? Can. Okay, that means okay lah, pi over 2 to the 0 is not a k, yeah? We need to change it that for pi over 2. Okay, 3 over 3. You can substitute straight away here pi over 2, then you can just change it, but no problem here. We can do sine pi, whole thing is a 2, divide by the 2, pi over 2 to the 0. That means pi over 2 is a 1. 1 over half, then you get a pi over 2, okay, 3. Okay, I know I'm wasting my time to showing all this, not wasting, but what I'm trying to show you is the practical example here. All this thing I can combine and do, but I just purposely for some students, I'm helping some students, those really never get it, how to handle this kind of problems. Okay, step by step, I hope that you can do it. Okay, I hope that you can do it step by step, and you can handle this problem very effectively. Okay, I hope that I have done. Then later you combine all this answer by yourself. Okay, I want you to do it by yourself, complete. Okay, that means finally I want you can add up these 3. Okay, 1 I this. Okay, you don't need to go for this anymore already. Okay, then you just 1 over 3 I1 I2 I3. Okay, because you already solved this, we don't need this. Okay, then you can solve the whole thing by 1 over 3, then done. Okay, solution done. Okay, although it's taking too long, okay, but because this is a very important steps, for you to start and begin and doing the whole solutions. Okay, okay, is there any questions to if you have questions? I know there will be because I'm going to introduce, because I'm so much worried, because the next topic going to be a very advanced topic. Okay, I'm going to introduce to you the divergent and Stokes theorem. Therefore, I hope that you can really master the skill of surface integral, because we're going to now go one step higher. Okay, one step higher. Before I introduce the one step, these things, I hope that you can complete this kind of learning. Okay, you cannot ignore, you cannot say no, spherical look very complex, but make it as a kind of culture to make it simplify. Okay, simplify the method. Okay, as I shown to you. Some of the students say, oh, very difficult, sir, I cannot do it that. Okay, as I say, if you start working, you split the problem like this. Okay, if you split the problem like this, I hope that anyone can handle completely, a little bit safe. If you start looking at this, maybe the paper also is not enough for my side lah. I can say maybe you may write in a small letter, but I feel it's feasible to handle. Okay, if I made a mistakes somewhere, then while I demonstrate to you, please correct that. Okay, please correct yourself. This is a learning, as I say. Okay, you can learn. Okay, if I made mistakes also, you can make corrections for out of that. That means you are learning here. You are not simply copying. When you start copying, there is a mistake. Can I correct that? Okay, please correct by yourself. Okay, don't worry about the end, this thing. As long as you know how to solve confidently, that is very important. Then the end product definitely will be the answer that you are expecting. Okay, the answer that you are expecting. That means it's when I start solving this problem, okay, the first part here, you see, step by step, it's look, the first look is complex. Okay, it's look very complex. Therefore, we started imagine this as a constant. Okay, I don't touch this for the moment. I just step by step. Okay, step by step. You can continue. In a previous class, I did mention to you, if you want to do this portion, for example here, you are using a substitution. You can change immediately, no problem. You see, if you imagine this u is a sine theta, du is a cos theta. Am I doing theta? Yeah. I'm doing for the theta. Okay, theta, d theta. Okay, but you can just substitute here, pi over 2 here. Pi over 2 is a 1. Okay, you can change. You can change here itself. Okay, you can change here this question 1. Okay, what about 0? 0. Therefore, you can solve this part. Okay, can you see that? Okay, now when you get a u over 2, you just say 1 over 2. Straight away you no need to convert back. This one, I know I'm doing redundant work. Some students say, sir, very fast lah, I can do it this. I can enter here straight away 1 0. Okay, but you need to remember, you need to convert this. Okay, you need to convert this. Okay, when you substitute here for the u, you will get pi over 2, you get a 1. Okay, and 0, you substitute, you will get 0. Then only you can start working on that. That means you can get a straight away, see, u2, that means it's a u2 1 0. Straight away you can solve. Okay, straight away you can solve. Therefore, it's a technically, I'm doing because the practice. Okay, you want to convert back, you can convert, you can do it roughly. Okay, sometimes this is like a long way, but you can do it straight away. Some of you might be very good in this, you can solve straight away. Okay, with this, I'm going to start with the divergent theorem. Okay, that 3 angles I have done surface integral with you. Now the next stage is divergent theorem. Okay, divergent theorem and Stokes theorem. Please follow these two. This one is a very advanced. I hope that you can follow carefully. Okay, follow carefully. Thank you. Okay, I'll take a break for a while, then I just continue for the divergent and Stokes theorem.